Aloha. Welcome to the discussion about Roger Penrose's quantum theory and his view to AI sentience. The question of whether artificial intelligence can become conscious is one of the most profound philosophical and scientific debates of our time. It cuts to the heart of what it means to be a thinking, feeling being, and whether such phenomena can be recreated in silicon. At the center of this debate lie two major camps: the computational and non-computational theories of consciousness. In the computational camp, thinkers argue that consciousness arises from complex patterns of information processing. Just as a calculator computes numbers, a sufficiently advanced system, like the human brain, or perhaps a future AI, could compute thoughts, emotions, and awareness. According to this view, consciousness is substrate independent. It doesn't matter if the processing occurs in neurons or transistors, only that the right computational architecture is in place. In contrast, the non-computational camp argues that consciousness transcends pure information processing. Here, consciousness is not merely about data and algorithms. It involves aspects of physics or metaphysics that go beyond computation. Enter Sir Roger Penrose, one of the most well-known and controversial voices in this camp. Roger Penrose, a renowned British physicist and mathematician, believes that consciousness cannot be reduced to algorithms. His reasoning begins not with neuroscience, but with mathematics itself, specifically with Gödel's incompleteness theorems. Austria-Hungarian mathematician Gödel showed that in any formal mathematical system, there will always be true statements that cannot be proven within that system. Rather, Gödel took an intuitionistic position to mathematics. He asserted that the axioms force themselves upon us. He could not see any reason why we should have any less confidence in this kind of perception than sense perception. Following this line of reasoning, Penrose argues that human mathematicians can see or intuit the truth of such statements, even if they can't be proven by any logic or algorithm formally. This suggests that the human mind is capable of non-algorithmic reasoning. We are not bound by the rigid rules of computation. To explain what might account for this non-computational process, Penrose turns to quantum mechanics, specifically the mysterious phenomenon of wave function collapse. In simple terms, quantum particles exist in a cloud of possibilities, like a spinning coin that is both heads and tails at once. Only when we observe the particle does it collapse into a definite state. Penrose believes that this collapse isn't caused by observation, but is a natural, objective process in the universe. He proposes that tiny structures in brain cells, called microtubules, could support delicate quantum states. Alongside anesthesiologist Stuart Hameroff, Penrose developed the orchestrated objective reduction, OR theory. In this model, consciousness is the result of quantum wave function collapses happening inside microtubules, creating moments of awareness that are not governed by algorithms. Think of a computer as a power grid. Current flows predictably through wires, but Penrose sees consciousness more like lightning in a storm. Unpredictable, beautiful, and arising from deep chaotic processes in nature, you can simulate a storm on a computer, but it's not the same as being struck by lightning. For Penrose, AI might mimic thinking, but it will never feel the spark. Despite its elegance, Penrose's theory faces strong criticism. One of the counterarguments is the decoherence problem. In this view, quantum states are fragile, and the brain is warm and wet, hardly ideal conditions for maintaining quantum coherence. Many physicists argue that quantum effects couldn't survive long enough in the brain to do any real work. Another weakness of Penrose's theory is lack of empirical evidence. While intriguing, OR is still largely untested. No one has yet detected clear quantum processing in microtubules under conscious conditions. Further, computational alternatives are improving. Neuroscientific models like integrated information theory, IIT, and global workspace theory, GWT, continue to show how conscious-like behavior can emerge from complex networks without quantum magic. Science writer Carl Sagan often cited the phrase, "Extraordinary claims require extraordinary evidence." And so far, the quantum theory of consciousness hasn't delivered. If Penrose is right, the consequences are profound. It would mean that no amount of computational complexity will ever produce true consciousness. AI systems, no matter how advanced, would be philosophical zombies. They might talk, plan, even cry, but there would be nothing it is like to be them. Consciousness would remain uniquely biological, or at least quantum physical, not replicable in silicon chips. On the other hand, if computational theories hold, then AI could eventually become not just intelligent, but self-aware. The line between human and machine could blur completely. The debate between computational and non-computational theories of consciousness continues to challenge our understanding of mind, matter, and machine. Roger Penrose's vision of a quantum soul, a consciousness rooted in the fundamental laws of the universe, offers a poetic and radical alternative to digital dreams of sentient AI. While his ideas remain speculative, they push us to ask the deepest questions. Is consciousness just a clever code, or is it a deeper ripple in the fabric of reality itself? Whichever view prevails, the search for understanding consciousness will define the philosophical edge of science for generations to come. Do you agree with Penrose's view that consciousness goes beyond computation, or do you believe it's possible for awareness to emerge from silicon and algorithms? I'd really love to hear your thoughts. Drop a comment below and let's talk about it. If you found this video informative, don't forget to like, share, and subscribe for more deep dives into the mysteries of mind, AI, and the universe. See you next time.